Hello my dear friends, in this class we will discuss about another type of experiment, another type of fringes which is called as Fizeau experiment. So Fizeau is nothing but in 1859 H.L. Fizeau from France did an experiment and got some fringes and he got a awesome result. We'll see what the result is. So he performed this experiment. First thing is that why he performed the experiment. Whatever scientist does the experiment, there is some reason behind the experiment. You also think, suppose you wanna do some experiment. If there is no reason, you are just like a mad. Without reason, you are doing experiments means nobody will do like that. So there is must some reason for which he did that experiment. First thing is there. What is the reason? The reason is that suppose here you have a light. Your sunlight is here, or normal light is there. Normal lighting means whatever the light source, and this is a medium. Okay, here you are the observer. According to the Fizeau experiment, the light, not Fizeau, we know that light propagates in 5 into 10 to the power 8 meter per second. That is the velocity of light. It's fine. In vacuum or in free space, we say that light propagates in this velocity of light. And one more thing, suppose you, this is a medium and you are projecting a light through the medium. Someone will ask you, what is the velocity of this light through this medium? What will the answer? Suppose this one having a certain refractive index. Solid means a medium means refractive index will be there. So the velocity will be C by N. This is the formula. To get the velocity of any unknown material, if you know the refractive index. So this is the formula, and we know light propagates in 5 into 10 to the power 8 meter per second. Okay, fine. Now I will take one medium. This is a medium having a certain refractive index. Let's say this medium having a refractive index mu. Light is propagating here from this side to this side. We know that this light also means this light also will propagate in a velocity of 3 into 10 to the power 8 meter per second. That's obvious. It's very established property of the light. We know that. Everybody also obey that. That's also right. But thing is that what Fizeau did. Fizeau did that if light propagates in 3 into 10 to the power 8 meter per second in a constant medium, if the medium will be changed, light is there, observer is there. What he thought? He thought to change the medium. This is the medium. He tried to change the medium. Means there will be some motion in the medium. Some changes in the orientation of the medium. Then what is the change in the velocity of light? Is it still 3 into 10 to the power 8 meter per second? Or there is some increase or there is some decrease in the velocity of light? He did the experiment. You got what I told? I told that in the free space, if the space is constant, space means if the medium is constant, if there is a medium means some refractive index will be there, and the refractive index n means the velocity will be this much, but there is some certain velocity according to the refractive index. The medium is constant, so 3 into 10 to the power 8 meter per second is the velocity of the light. The Fizeau did that. He changed the orientation, he changed the medium, and he observed whether the velocity of light is changing or remaining 3 into 10 to the 8 meter per second. He also performed an experiment. He took two hill. One hill was standing and another hill there was a source, and the distance between the two hill means there another hill, here another hill. The light source was here and he was standing here. Here he set up some experiment in between, and this is 8.5 kilometer. You can imagine how long is it. So now we will see what is the experiment. How did he prove that light also changes? If the medium is changing with respect to the source and the observer, the velocity of the propagating light also changing means either increasing or decreasing. We'll see that how it's changing. He considered a light source. To make it parallel, he considered a convex lens. So light sources are coming like this. From here, the light will be split into two lines, means in parallel line. Now what he did, he took two tube of water, two tube filled with water. Suppose this is one. This is another one. You'll be thinking why I did this too. I told that these tubes are filled with water, so water is there. I am injecting the light this side and the light is coming out this side, this way. That means the direction of, not the light, this is water. The tube is filled with water. The water is coming in this way and going out in this way. That means the flow of water is in this way. It's coming like this. In this case, the water is going inside this way and going outside this way. That means water is going this way, like this. This is your tube 1, this is your tube 2. I set these two system as I will get two tube with different direction of the light, different direction of the water. That means water in both the tubes are moving in opposite direction. So this light enters inside the tube with a certain velocity. This light also enters inside the tube with certain velocity. Now these two light will come out. Here I will take one more lens. This is your lens L1. This is your lens L2. Why I took the second lens? According to theory, if two parallel lines are coming and it's facing a convex lens, these two will meet at a certain point at the focal length of the convex lens. So I will take here a normal fully silvered mirror. Means backside is completely silvered. There will be no transmission, only reflection will be there. See, this light went like this. After meeting here, it came this side. This light went like this. After meeting here, it went like this. Here I can draw a normal. Why I did the normal? What is the angle of incidence of this light? The reflection will be like the same. Same thing. This light will be reflected to that side. This light will change the path. See, this light is going like this, and here this light will reflect and will come in this way. Means the light. Suppose I will take this is light 1, this is light 2. Light 1 after facing this mirror is coming through tube 2. Light 2 after facing this point is going through tube 1. So this light came like this. I will keep here one more mirror. This is also silver mirror. This light will come and this light will reflect like that. This light will, so it will reflect. This is the point. This is a very important experiment he did, because he proved that light also changes. When light propagates through a medium and you are changing the motion of the position of the medium, then the velocity of light is changing. It's a very interesting thing. So you understood the experiment how he performed, considering tube T1, T2, this light going like this, here it's reflecting again, it's coming back, and the light going this way, going like this, reflecting here, going this way. This light came, I kept a mirror here, so it reflected like this. This light also reflected like this. These two lights are meeting each other here. See, there is a path difference. This is your delta. So, whatever will be the path difference here, accordingly you will get your maxima or minima. Accordingly you will get your constructive or destructive interference. Your fringes. This is nothing but your Fizeau fringes. From the Fizeau fringes, he got a shift in the fringes. When the medium is constant, he got another fringes. When he changed the medium means water is going this way, coming this way, means water flowing in this way in this tube, and water flowing in this way. Means when he started flowing water in opposite direction in both the tubes, he got a shift in the fringes. And that's why he concluded that the velocity of the light is also changing due to the change in the medium. We'll see mathematically how we explain that the velocity of the light is changing. Now we will derive mathematically how mathematically Fizeau show that there is a changes in the phases. There is a changes means there is a shift in the fringes, so that conclude that the velocity of light is changing in the medium due to change in the medium. So he considered that, let's say the refractive index of water of the medium is n. This is the refractive index of the medium, and the velocity of light in that medium will be Vx dash c by m. This one I have already told. If you have a medium and the refractive index of the medium is n, then velocity of light in that medium is velocity of light in vacuum divided by the refractive index. So this is the velocity of the light inside the medium. Let's say the water is flowing in velocity of u. Velocity of water be u. These two you remember. Thing is that I told Vx is the velocity of light inside the medium, velocity of the light, and it is the velocity of water in u. I think you might have studied relativity. There is a concept called as relativity. Suppose something is happening in one frame of reference and we are standing in another frame of reference. So whatever we are observing, that same thing is not observed by the observer present in another reference. You will be moving in a train, you are sitting inside the train, some persons are standing outside the train. While the train is moving, you are watching outside, you are also getting that the trees are also moving. But in real, is the trees are moving? No, trees are standing, they are stationary. The train is moving, that's why we are getting the trees are moving also. That is due to the concept of the relativity. You will study in the chapter your relativity. So your light is propagating in the velocity of Vx dash and your velocity of water is u. When this case, when somebody, suppose I am the observer and if I am sitting inside the tube, just notice what I am saying. If I am sitting inside the tube, then these two are for me. That means if I am sitting inside the tube, Vx dash is the velocity of the light inside the tube and u is the velocity of the water inside the tube. But if I am standing outside, means wherever I am now, I am watching it from here, means I am outside the tube and I am watching what is happening inside the tube, then that will be different. So in that case we have to use our velocity addition formula of the relativity. What is that? Let's say I will erase this part, students. It will be easy for me to write, to derive the expression. Let Vx be the relative velocity. So according to velocity addition formula from the relativity chapter, what will happen now? That will be your Vx1 plus u1 plus, and this will be your u Vx dash by c square. Okay, this is a formula in the relativity. Suppose you have a velocity v1, v2, so the relative velocity will be your v1 plus v2 1 plus v1 v2 by c square. You will study this one in the case of relativity and you can better understand this one. These experiments also valid for the chapter relativity. Okay. In case of u, I can put, in case of Vx dash, I have already told you Vx dash is nothing but your c by n. Let's put here your Vx dash is c by n. I told I am taking the addition, that may be subtraction also. So here I should introduce a plus minus sign. This is u 1 plus minus u into c by n divided by c square. So what you are getting? C by n plus minus u whole divided by 1 plus minus. Your cc will be cancelled. So you will get u by cn. U by nc. And you know the velocity of the light is the highest speed observed by anything in the world. So c is your very much high. So your C is much more high than your U. So U can be neglected. I am erasing this part. So I can write it as C by N plus minus U 1 plus minus U by NC to the power minus 1. Here you can put your binomial expansion and you can neglect your highest terms and you can keep only two terms. So let's say I will keep the two term, first two term, try to do it. I have already done such type of expression in previous cases. So only a minus will be introduced, so it will be minus plus instead of plus minus U by NC. Now what will I do? I will multiply. So this will be your C by N minus plus C square by N square C plus minus U. So this will be your U square minus U square by NC. As I told, your C is very greater than U. So this term can be neglected. So let's neglect that term. This term is neglected now. What else left? C by N remain as usual. Plus minus U. This is plus minus U. I took common. After taking common, I am leaving here. Your C get cancelled. I did a mistake. This is U square by NC. After taking common U, what will be? This is U square. So it will be your 1 by N square. See, you students, you got one thing. When there is no change in the medium, that means the water is constant. Here water is moving in opposite direction. When the water is constant, what we got? The velocity is Vx dash equal to simply C by N. But when water is moving, we got there is some shift in the velocity. That may be increasing, that may be decreasing. And how much is that? This is the extra part we observe. This is important. Notice it. That means due to the motion of the medium, when the light is propagating to a medium and the medium is in motion, the change in the velocity of the light is of this amount. That means the velocity that depends upon your velocity of water and the refractive index. How the dense is the medium and what the refractive index of the medium. So what he did? He did an experiment. So he have taken some constant, he have taken some values. So according to him, I will put some values now. So your change in means del Vx. This is the real one in constant case. This is the changes one. So the changes between these two will be U into 1 by 1 minus N square. So what he did? Here consider your refractive index of water is 1.33. If you put here, you get, after solving, how much he got? He got something like that, 7 by 16 U. You do it yourself. How much is getting? 0.44 U. Suppose he got a fringe here. Without the motion of the of this medium, he got such type of fringes. But when he took the motion of the medium, motion of the water, the fringes is shifted like this. That is proved by the velocity of the light. That means the velocity of the light is changing half the velocity of the water. 0.44 is nothing but 0.5. That is nothing but your 1 by 2. Means your U by 2. So your del Vx is nothing but your U by 2. See how beautifully he explained he derived the derivation. And lastly, I will explain one thing. according to Fizeau, if you have a light source here and you have a medium here and you are an observer here, okay, this medium, suppose you are changing the motion of the medium, the velocity, suppose the velocity of the medium be u, okay, the normal velocity of the medium be u, the light is going this way, means here when the medium is constant, the light is going in 3 into 10 to the power 8 meter per second. Now I will change the medium, suppose I will rotate the medium, so how much the velocity of light will be? There will be a change of velocity of light. How much is that? That will be your u by 2. Means suppose the velocity of water is your 50 kilometer per second. Okay. Now I will take this in meter. Suppose 500 meter per second. 500 by 2, your 250. So your 320 by 8 plus minus 250 meter per second. That means after changing the motion of the medium, that means either you may rotate, whatever you change the appearance, the velocity of the light either will decrease by 250 meter per second if the velocity of water is 500. I just assumed roughly, if the velocity of water is 500 meter per second, as per the formula, the light will change u by 2 times. U is nothing but the velocity, so 500 by 2, 250, so 3 10 to the power 8 plus minus 250 meter per second. That is very less, and because power here 10 to the power 8 means you can imagine how high is that. Somehow whatever be, power may be high, but there is some change. That thing is proved by your Fizeau. This is a very beautiful experiment. Thank you so much. Focus on this one and try to understand this. If you are not getting anything, you are not understanding, then please contact me. This is very interesting thing. Thank you.